All right, welcome everybody to another live stream. I did kind of have to change things a little midway. I was going to do a open Q&A tonight, but what I decided was we still had one more quiz that I wanted to kind of cover for my students. So that is actually going to be the mode of this live stream tonight. I did have some questions, though, that I did want to address for you guys, so I will come up to those, and then obviously if I do have some time after I've covered the quiz, then I will I'll answer those questions as well. So if you do have any questions throughout the live stream that you're going on, either for any of your own classes, homework, preparing for your final exams, then go ahead and let me know. But what I'm going to do is I think we're going to do like a kind of next 8 weeks, just do a live Q&A live stream in preparing for your final exam. So I think actually what I'm going to do is I'm going to take our final exam review and actually start doing certain sections from that, because I have a lot of questions on that review. So I could do a 4-hour live stream, but who really wants to sit for a 4-hour live stream? So I think what I'll do is I'll take each one of those sections and break it up into a live stream. And then what I'll do is I'll do that for a half an hour. And then obviously for the last half an hour, what other questions you guys have as you're preparing for your final exam, we will do that. So either way, that's how we're going to look. So I see that Macy, Shalina, Alpaca, Jan Sports, Junie, Eddie, good to see you guys here. Zarif, Victor, Lavi, Alan, Exadamo, good to see you guys early and on. That's awesome. So again, guys, if you guys do have some questions, please feel free. Naris, you asked me about elimination substitution for my math class. Yeah, feel free. I mean, if you have a particular problem, that would be preferred rather than me making up a problem on the spot. So if you have a question that you want some help on, then give me more specific you guys can be on your questions. The easier it is for me to, kind of quickly go over them. But otherwise, I want to get right into the stream or right into the quiz. But if you guys do have some specific questions you'd like me to address, feel free to guys add them into the chat. And what I do is after I am done here with these first 4 questions, then what we do is we go ahead and get into the multiple choice. So this is something that I gave to my students for their quiz, and they will be taking their test soon enough. So I wanted to kind of just explain it, so therefore they could kind of see, where they went wrong, and if they did make some mistakes, and kind of just better understand the material. So there we go. Let me just make sure I got everything here. All right, perfect. So let's get on with the first question. So the first question says, write the equation of the parabola given the directrix x equals 1 and focus -2, 2. So what I told students in this to do when you're given problems and you need to write the equation, the best thing to do is just to plot the information. Or am I trying to draw that? All right, so let's go ahead and plot a line x equals 1 and a point -2, 2. And that's going to be too big, so let's go back and change that to there. Okay. All right, so plotting this point here, x equals 1 is going to be a vertical line. I'll just do a dashed line. All right, and then I have a focus at -2, +2. And that is the focus. Now, the important thing that we looked at in our investigation of the parabola was that a couple things. One, that the vertex of the parabola was midway between the focus and the directrix. So therefore, if we look at this distance here, if we just kind of count on the graph, we have 1, 2, 3. Right? So the distance from the focus to the directrix here is 3 units. Well, the vertex is going to be right in the middle there, right? So what that means is basically the distance from the vertex to the focus is going to be, half of 3, which would be 3 halves. A lot of students used 1.5 and so on and so forth. But another thing we could look at here is we could say 2p is equal to 3. Is equal to 3. Let me just redraw that. Now, P, it is kind of interesting here. I don't really actually want to use that P because P is something really important. P is not only distance, but it's also direction, right? So I'll just maybe put this in the absolute value. Well, anyways, I'll just run with it on there. So therefore, P is equal to 3/2. Now, it's very important, though, for us to understand that it's not just distance. P is not just the distance from the vertex to the focus. It's the distance and the direction. So, anyways, if we're a unit and a half away, let's actually do this a different color. Let's do this as purple. So if we're a unit and a half away, we can say like here is going to be our vertex. Well, so the distance from your vertex to your focus is going to be 3/2, but it's going to be 3/2 in the negative direction. And this is very, very important for us to understand. So therefore, our p-value is actually going to be a negative 3/2, right? So since this is negative, what that means is our parabola always opens up towards our focus, right? The axis of symmetry of your parabola is always perpendicular to our directrix. So now that we know that we have a horizontal parabola, we know that y is going to be squared. So the general equation for the parabola, for a horizontal parabola, would be y minus k h, y minus k, h minus x, x minus h. There you go. Y minus k squared equals 4p times x minus h. All right, so the 4p is always with our linear term. Y is squared because it's going to be opened up horizontally. Now, we do need to understand where our vertex actually is. So we know that the y coordinate is still going to be 2, right? So we know the y coordinate here is 2 because obviously it's going to lie on the same axis as the our axis symmetry as the focus. However, it's 1.5 away from negative 2, which is just going to be a negative 1/2. Okay, so just by looking at the graph, you can kind of like figure out where exactly your vertex is going to be. Now, we just got to plug in our information. So, therefore, we have y minus k, which is 2. I'm just going to use parentheses so you can see what I'm doing. And then 4 times a negative 3/2 times x minus negative 1/2. All right, so y minus 2 squared equals, you can do the 4 divided by 2, which just gives you 2, so that gives you a negative 6, and then x minus a negative 1/2 is x plus 1/2. Okay, so there you go. That was the equation of parabola. Obviously, I did not elaborate how to write the equation, if it should be in standard form or, general form or anything else. So therefore, this was acceptable. I don't think any students went that extra step here to put it in like general form. So that's perfectly fine for at least on this quiz. All right, the next one says find the radius and center of the circle. So obviously you guys can see that we have x squared and we have y squared. It tells us actually it's a circle. And we know that if we want to put this in the formula of our circle, which the general formula here would be x minus h squared plus y minus k squared equals r squared, right? So the center is going to be h and k, and obviously whatever it's equal to is r, which r squared, where r is your radius. So the main thing we need to do then is go ahead and get our problem to be to get binomial squared. So to do that, we're going to have to complete the square. So I'm going to use some color variations on this one. So first thing we want to do is group the variables. So x squared minus 2x plus y squared plus 2y equals 2. Now I'm just going to put the 2 here on the other side just to make sure that, just so it doesn't get mixed up with everything else, all right? All right, the next thing I'm going to do now is I'm going to create here a trinomial to go ahead and complete the square with. All right, so what I'm going to do is I'm going to group my first 2 terms here and group these 2 terms. Now, fortunately with this, in this problem, you can see that both of my quadratic terms here inside these parentheses have the coefficient of your quadratic term is 1. So therefore, all I need to do is take my middle term, divide it by 2, and square it. So negative 2 divided by 2 is negative 1. Negative 1 squared is 1. And then here I have, Now that's really weird. Okay. It like stopped working for some reason. In this one I have 2 divided by 2 squared, which is going to also equal 1. Now, it's very important when we're going to be adding these in there. Now, again, these are the values that create perfect square trinomials, all right? Sometimes we call them the values C that complete the square. But it's going to be important if we're going to add these values that we just created inside these parentheses to create a perfect square trinomial, then we just got to make sure that we do that to the other side, all right? So I'm going to use a lot of color coding, a lot of coordination here, just so people hopefully can see what I am doing and where these numbers are coming from. It doesn't help that they're both positive ones, but whatever, we'll just have to work with that. So I added a 1 here on the left side, so therefore I need to add a 1 on the right side. I added another 1 here on the left side, but I didn't really add it because I forgot to write it in there, so let's go and fix that. So then I'm going to add another 1 here to the right side. So now, again, what I have done is I've created a perfect square trinomial. Therefore, I can factor these down to binomial squared. So now it's in the form exactly what I want it to be. And therefore, 2 plus 1 plus 1. Let's just erase that. It looks bad. Is equal to 4. Now, again, understanding our general form, we can see that h is going to be 1. H is going to be 1, y is going to be negative 1, because notice how it's like the opposite sign here, and then r squared is equal to 4, so therefore r is equal to 2. So I'll write that in red here. So the center, just make sure you're using those opposite signs. A lot of people don't want to get confused with like negative 1 and 1, but it's going to be 1 comma negative 1, and then the radius 4 is equal to r squared, so therefore r is equal to 2. So radius is going to be 2. Okay, and there you go. All right, let's do the next one. Identify the equation of the ellipse given the foci, -2, 1, 4, 1, and the vertices, -3, 1, and 5, 1. And also just kind of a quick little reminder for you guys, you know, as you're watching through this live stream, I will take a break after I'm done with the free response questions and address any questions you guys have here. So please feel free to just kind of let me know on that. I'll do a quick little scan here to make sure that I have every questions addressed before I move on to the multiple choice. All right. All right, so let's go ahead and graph it again. Let's use green because that was nice to use for graphing purposes. I don't really know why, but sure. So we have -2, positive 1. We have 4, 1, 1, 2, 3, 4. We have -3. Oh, let's label those. So that's foci. Okay, now this again does say an ellipse, so we know the foci are going to be inside of your vertices. Then we have -3, 1, and we have 5, 1. Okay, so there's a couple big things that are happening right now. First of all, I noticed that the transverse, or I'm sorry, not the transverse, I'm talking about hyperbolas. The major axis is going to be horizontal. So automatically, I know the general equation that I'm going to be using here is going to be x minus h squared all over a squared plus y minus k squared all over b squared is equal to 1. Okay, I also know the relationship between a, b, and c is going to be a squared minus b squared equals c squared. So just by identifying this, just from looking, by plotting the points, I came up with my general equation for the ellipse as well as the relationship between a, b, and c. Because again, remember that does change when we're dealing from an ellipse to a hyperbola. Also, from this point, we can also determine what the center is. So remember, the center is the midpoint between the two foci. It's also the midpoint between the two vertices. Now, if we're dealing with more complicated points, we could use the midpoint formula. In this one, it looks like it's rather simple, and we can see that the center is going to be at 1, 1. So that's kind of nice. All right, but again, we don't really need to identify this. Actually, we do need to identify the center because that's h and k, right? Now we need to identify a and b. So we got to understand what is the distance from the center to your foci as well as the distance from your center to your vertices. Well, the distance from your center to your foci is 1, 2, 3, and that represents c. And then remember, oops, that's 3. But that is the value c, so let's write that as center. Okay, that is the value c for that in formula. And then the distance from the vertice to your center is 1, 2, 3, 4, and that is going to be your a. So A is equal to 4. And just again, remember FYI, B represents the distance from your center to your co-vertices, and that's going to be along the minor axis, which is perpendicular to your major axis. So we know A, which is 4 squared, or 4, square it, minus we don't know B squared, and we know C. All right, so now all we got to do is solve for B squared. So we have 16 minus B squared is equal to 9. Subtract 16. Negative B squared is equal to a negative 7. So therefore B squared is equal to 7. And therefore I'm just going to leave it from there. I'm not going to solve for B. I'm just going to leave it as B squared because that's all I need for my formula is B squared. So now I have my H and my K. I have my A squared. Well, I have A squared, which is going to equal 16. And I have B squared, and that's all I need for my equation. So, and that's all I was asking for, right? Yep, just write the equation. So I'll do x minus 1 squared all over 16 plus y minus 1 all over b squared, which is 7, equals 1. And there you go, ladies and gentlemen. So that is the ellipse. So we covered the ellipse, the circle, and the parabola. Now it is time for the hyperbola. Now, the major thing on this one is we're given the equation. So we can now identify our h, k, a, and b just from this equation. So remember, when we're looking at a hyperbola, obviously h is still with x, k is always with y. We notice that subtraction sign is different than from the ellipse. And we can also recognize that a squared is not always the larger number, but in this case it's always the positive number, or typically always written first because a squared minus b squared. So just from this information, we know that this is a hyperbola written in this form. And this is a lot of students made where they made their mistakes, was just mixing up the forms. Okay. All right. So now we know our center, which is the first thing we need to figure out. The center is just h and k. So that's going to be 2 comma negative 3. We know a squared is equal to 7. And we know b squared is equal to 9. Now, to find c squared, let's do c squared here. To find c squared, we got to use the equation, the relationship between a, b, and c. But remember, that's a little bit different here for a hyperbola than it is for an ellipse. So for a hyperbola, it's going to be a squared plus b squared is equal to c squared. So therefore, that's going to be 7. No, I wrote that. Yeah, that's going to be 7 plus 9 equals c squared. So therefore 16 is equal to c squared. All right, so now we know what c squared is, which is going to equal 16. So now that's not really as much helpful though if we're trying to find the center and the foci, because we need to actually know what a is, b, and c. So a then is equal to the square root of 7. B is equal to 3, which is the distance from the center to your co-vertices, and C is going to equal 4. All right, now it might also be helpful just to kind of do a rough little sketch of this graph, just to kind of see, just kind of get an idea of what's going on. So let's go and scroll that up here. All right, so we're at 1, 2, negative 3. Okay, so there's your center. Now, it's important that a squared is under the x. So what that tells me is my transverse axis is going to be horizontal. I'm trying to write this really fast. But that's very, very important for you to understand, because what that means is the foci and the vertices are going to lie on this transverse axis, right? So actually, you know what I'm going to do? I'm going to just dash line that. Let's redo that. Let's do this as a dash line. All right, so now, how far does the vertices and the foci lie from the center? Well, let's do the easy one. The foci is going to be 4 units away, but again, they lie on the transverse axis. That means they're going to be moving left or right. So let's go ahead and write this out and then actually figure it out. So foci is going to be 2 plus or minus 4, comma, negative 3. Right? Basically, what you're going to the right for and going to the left for, but you're going left or right because a squared is under the x. So to simplify that, it's 6 comma negative 3 and negative 2 comma negative 3. All right. So therefore, I can just kind of plot those points here just to kind of get an idea of what I'm looking at. What was that? 1, 2, 2, 3, 4, and then 1. There you go. So those are my two foci. And again, the graph wasn't required, but I think it's just helpful to kind of better understand what's going on here. Let's see here. My vertices are not as nice to be able to graph, but again, just the main thing to understand is that your vertices lie on the transverse axis just as long as your foci. So that's going to be up, that's going to be left and right as well. So we'll just do 2 plus or minus the square root of 7 comma negative 3. Now, we can approximate this for graphing purposes. The square root of 7, 2.64575513, just a rough approximation, but that the square root of 4 is 2, and the square root of 9 is 3. So the square root of 7 is going to be some decimal between 2 and 3. So, just estimate. You don't need to know 2.64575513. You just need to kind of get it close. So let's just go 2.6 here, there, and 2, 1, 2, and then half there. There's vertice, and so you can see it would look something like that. All right, now the last thing we need to do is also talk about the asymptote. Now, this is an equation that a lot of students had trouble remembering. So the important thing here for the asymptote is, since we have a horizontal transverse axis, y is equal to plus or minus horizontal transverse axis is b over a times x minus h plus k. All right, well, we already know b, which is 3. We already know a, which is square root of 7, and then plug in our h and k. So y is equal to plus or minus 3 over the square root of 7 times x. Let's see, that's minus 2, and then it's plus a negative 3, so it'd be a negative 3. So plus a negative 3 just turns into minus 3. So there you go. That is the first set of problems for you guys. It's actually from there. And so in this case, we worked on the hyperbola, the ellipse, the circle, and the parabola on the quiz. All right, and so now what we'll do is we'll go ahead and work on some multiple choice questions. But before I do that, I'll kind of see if you guys have any questions from those of you guys that are in on the stream. Ali, come on now. Ali, it's not showing up. All right. Yes, Ali. James Schwartz has been in for a while as an essay is generally a piece of right. Oh, okay, you're ever responding to someone else. Does that have any tips on how to solve math problems quicker? Yeah, and there's a lot of different math problems. It kind of really depends on what math problems that you're really trying to solve quicker. No, James Schwartz, it's not just getting smarter, but a lot of it is a lot of people will, and exactly who posted that? Hope. Yes, exactly. It's just practice. The one thing I tell the students is, a lot of people feel like, oh, you have a math brain, right, or anything else. But no, it's just basically when you've done practice, or if you've focused on something, your brain understands to make connections, and it also looks at things that you may have overlooked. But so just thinking that you can all of a sudden, do math and it's going to be quick and it's fast and it's easy, is crazy. You got to put in the work, you got to put in the time, you got to put in the effort. So therefore your brain can make those connections. And, some people are going to have a little bit easier time. That is true, with it. But that's also just because of a lot of their experiences and a lot of their work that they have done before. And so, don't compare yourself with other people. It's always easy to say it than rather do it. Just because somebody's doing something quicker doesn't mean that you're at a disadvantage or you're not as smart as them. But that doesn't mean they have some different, connections. They probably have some different practice, and they, some things that their brain's able to make those connections a little bit easier. So, a lot of people will watch me do math problems like, oh, wow, you're so good at this. Like you do it. I'm like, you do realize what I do for a living, right? Like, every day I'm doing math problems. So of course, when I'm doing something basic, it makes it seem like it's the easiest thing ever for me to do it. And that's also because I've done it probably, 500 to 1,000 times in front of a group of students, or even recorded myself online, So, I really hope that you don't need to do it as many times as me to get good at it, and usually you don't. But, I'm kind of one of those, odd examples. People will compare themselves to me or like how they're doing their math, and I'm like, guys, that's not even a fair comparison. I'm doing math every single day. So, my brain has caught a lot of tricks, and, I try to give those tricks to you guys to help you out. So therefore, hopefully it doesn't take as much, but I don't know why I'm talking on that for so long, but hopefully that was helpful. All right. Jamboard is on the wrong video. Okay. Thank you, Jamsports. Yes, I am reading all of the chat. So I'm going to go back in there really quickly and just make sure. If I have any other questions, though, from you guys on this test. Looks like a big here. All right, guys. So I don't think I have any questions, or at least anything I'm not seeing. So it looks like we're pretty good. So we'll go through the review, or at least the multiple choice questions. And then if you guys do have any questions that you'd like me to address after the multiple choice, then I will be more than happy to go ahead and get that over to you. See, there's maybe... Looks like you guys are having some fun in the chat. All right, cool. Oh, man, a lot of you guys have a lot of chat that is getting flagged and not getting shown. So, all right. And asks what you do if you're getting problems wrong. Yeah, I mean, there's definitely a thing to like overstudying or overdoing, and obviously you don't want to, obviously you just don't want to keep on practicing things getting wrong. So I would say, take a break, come back to things, or maybe just go back to the easier problems. Really start with the easier, go back to the more basic problems, and then try to build yourself back up from there. And all right, Jennifer asked a question on this. Mr. McClellan, can you please explain why the foci on the transverse for that hyperbola question? I am getting confused with ellipses. Sure. And so study, thanks for the super chat. I really appreciate it. I feel like I've seen enough of your videos that I at least owe you this. Thanks for the study help. Well, you are very, very welcome. I do really, really do appreciate that. I hope that my videos, can help you guys out for wherever you are in your class. I mean, obviously this year has been a lot on pre-calculus, but obviously teaching Algebra 2, Algebra 1, geometry. So I really do appreciate that. So study, that's part of the reason for you guys, reaching out to me, not just through super chats, but also, you guys just even communicating to me, let me know, how the videos can help. That allows me to, want to keep on going, want to keep on producing videos, and doing stuff like this for the live chat. So, Jennifer, I'm not really sure where to address exactly on your question or what exactly you're asking. The main important thing is, this is the graph of the hyperbola. This would be the graph of the ellipse, and they're very similar to each other, the ellipse and the hyperbola. Obviously, I didn't get, what was the minor vertices? Square root of 7, so that's 2. So I've done something like that. 1, 2. So, it's right there. Those are covertices. So obviously the ellipse is like a elongated circle, right? But the main important thing, the major axis is where the vertices, the foci, and the center lie. Well, the hyperbola is basically like two parabolas now going away from each other. And you can see that again, it's not called a major axis, but it's really the same, same idea. It's just called the transverse axis. So again, the distance from your center to your vertices is A. The distance from your center to your foci is C. And that was true for a hyperbola as well as for an ellipse. One big difference, though, between a hyperbola and an ellipse is that equation, this relationship between A, B, and C. And we spent a little bit of time in my class understanding those A, B, and C relationships. But obviously when you look at the proofs, you can kind of see, where those equations kind of come from in that relationship. So it really depends on how deep you really need to get in with understanding A, B, and C. Otherwise, you can just know that they are some different equations from there. So hopefully that helped out. Junius, I'm not sure what your question, I can't really see. What your question is. You only answered one question. Millie Mikulski said, I'm from Scotland. Would you be able to go over SQA papers? I am not aware of SQA papers, but no, I'm not able to do like full-on papers or tests or stuff like that. But I do, and I'm not familiar with exactly math. I'm sure there's a lot of crossover there, but I'm not aware. And Lucan says, I only answered one question, but I'm not sure who he's responding to because I did 4 questions over here. But yeah, I'm trying to get into see how many you guys have here because the chat is going through and I want to get to the multiple choice, but I want to make sure I get you guys addressed. How much can I pay you to be my algebra teacher? Unfortunately, Barry, my time is very, very limited, but I do really appreciate that. And I do love trying to do the live streams and at least help you guys out from there. How often you do these videos? So Cassandra asks, how often do I do these videos? And I am planning on continuing this Monday, at least until the end of the year, until June. So I'm going to transition this Monday night from Monday night at like 9 o'clock instead of doing it as a, instead of doing this Monday night as, what was I going to say? Just like as doing the quizzes, I want to transition this to doing a Q&A and open up. So allow you guys to submit some questions. I need the questions a little bit more ahead of time, so therefore I can answer the questions. But yeah. I thought B squared went the vertical direction. It is longer in the hyperbolic. That's how I get you. Okay. So thanks, Jennifer, for clarifying that. So yes. So the difference here is, if you look at the equation of the hyperbola, so one thing, I tell my students a lot of this as well, that when you're looking at the ellipse, that a squared is always larger than b squared. A squared is always larger than b squared. And it's really easy to remember it. A squared is larger than b squared because a is the distance from the center to your vertices. So a squared is always larger than b squared for an ellipse. For a hyperbola, that's not always the case. So for a hyperbola, it's always a squared minus b squared. So basically a squared is positive, typically written first, minus b squared. So now to determine so it's always written like this. Now, instead of the denominators kind of like changing a and b, a squared is usually always first positive and then minus b squared. So now the x's and the y, the numerators kind of flip around. So the other equation that we have is y minus h squared over a squared minus x minus h. Sorry, I messed that up. That's k. Squared over b squared equals 1. So now if it was vertical, it would look like that. You'd have the y would be over the 7. So that's kind of like the difference of the ellipse and the hyperbola. So if you look at the equations, you can see how those differ. All right, so hopefully that cleared that up for you. Blaze Peanut says hi. All right. Walker Graham, good to see you. Exponential functions with polynomials. You're going to please give me some concrete examples that are detailed, and it might be helpful for you to, even take a picture for next time. Can you teach me domain and range? All right. No. Oh, Principal, if you have a question, like if you want me to go over domain and range of an equation, if you want me to go domain and range of a graph, of a table, of a set, anything you guys can be a little more detailed for. Well, Sareem, thank you very much. Or you are very welcome for that. I'm very happy to be able to help you out. So, all right, guys, I'm going to get to the multiple choice, and then I'll come back to some questions. But I don't want I want to make sure I at least get the questions here for these multiple choice, and then I'll come back and hang around here for a little bit. And for those of you that still kind of have some questions, but I apologize. Obviously, I want to make sure I get to this for you. But if you do have a question, make sure you type it in detailed, so therefore I know what exactly to do. I don't want to make assumptions or just make up some random problem for you that's not really going to address your issue. All right, so identify the conic by writing the equation in standard form. So in this case, we don't know what the conic section is. And you can see it's in general form. So Since in general form, I know that my A and my B are the same, I know it's a circle, so C is out. But now the only problem is that it's really going to make me determine what that value is. So I'm going to have to complete the square correctly. So dang it. It was a nice problem, but not as easy. So now what I need to do is go ahead and complete the square like I did last time. So I'm going to do 4x squared plus 40x plus 4y squared plus 16y equals negative 40. And then I will group the first two terms, group the last two terms. Now, again, in this case, this is a little bit different than the circle one. We notice we have a coefficient of 4 here, so I'm going to have to factor out that 4. So if I factor out the 4, I'm left with an x squared plus 10x. And I'm going to have to factor out a 4 here. So that's going to be a y squared plus 4y equals negative 40. Okay, so now we're going to do our b divided by 2 squared. So I'm going to do 10 divided by 2. Squared, which equals 25, and then here I have 4 divided by 2 squared, which equals 4. So now I'm going to add these values, but it's very important because of the distributive property. Whatever you add inside this parenthesis is being multiplied by 4. So when you add that same number to the right side, you also are going to have to multiply it by 4. So this will be 4 times x squared plus 10x plus 25. All right, and then plus 4 times y squared plus 4y plus 4 equals negative 40. All right, so I added things to the left side, but I didn't change the right side, right? So again, you got to understand, you're not really adding 25 on the left side. You're adding 25 that's being multiplied by 4. So when you add, therefore you can't just add a 25 to the right side. You got to add 25 that's being multiplied by 4. And in the same respect, we also have to add 4. Add another 4, and then that's being multiplied by 4. And kind of forgot the answer here. Oh, that was it. Okay. So now let's go ahead and factor this down. So it's going to be 4 times x plus 5 squared plus 4 times y plus 2 squared is going to equal, so let's go ahead and see here, 4 times 25 times 4 is going to be 100, so plus a negative 16, I'm sorry, 40, that's going to be a positive 60, and positive 60, and that's going to be a 76, doing my math in my head. And then I believe, yeah, that works. So now, again, that is not in the form, though. We have this form is in standard form where there's no coefficient. So to get this in our standard form, we're going to need to divide by 76. And I'm sorry, not divide by 76. I'm going crazy. This is the equation of a circle, right? So we don't want it to equal 1 like we did for a hyperbola and ellipse. We just want to get rid of these 4s. So to get rid of these 4s, I'm going to divide by a 4 on both sides. And 76 divided by 4 is going to be 19. So the answer here was A. Question number 6. Now, question number 6 is a interesting one. Because there's a couple things that are going on here. They talk about the focal width, which is 4 times the absolute value of P. All right. Basically the distance of, across the parabola through the focus. But the important thing to understand for this problem is when we're looking for our general equation, that it was in the form of, let's do this in, it's going to be x squared is equal to 4p times y. So the 4p is times the linear term, not the quadratic term. So what that means is I don't want this negative 4 here. I need to get rid of that. So what I'm going to do is I'm going to multiply by a 4 on both sides. So by multiplying by 4 on both sides, I get x squared is equal to 4y. By understanding that, by 4y, I wrote p. Okay, so now, in this case, from this idea, I can see that my center still at vertex is 0, 0. Sorry. I can see p is equal to 1. All right, so let's go ahead and plot this. I know that my quadratic is going to open up because x is squared and p is positive. So I can see that my focus is at 0. Oh, that's a negative 4. My bad. you got to multiply that by a -4. I was wondering, I'm like, I'm not getting my exact answer here. Uh-oh. All right, let's fix that. Let's just redraw that. How quickly you can get the answer. So let's multiply by -4, the reciprocal. All right, so now we have x squared equals a -4y. So therefore we can say, we could also rewrite that as x squared is equal to 4 times -1y. So p is equal to -1. So now my parabola does not open up, it opens down. So vertex is at 0, 0, and it opens down. So now our options goes down 1 unit. So there is our focus. So 0, -1, it's either going to be B or C. So it's not that one, and it's not that one. Now we just need to determine, well, which one between these two has a focal width that is correct. So again, P is 1. Our absolute value of P is 1, so 4 times P is C. So there is your answer, C. All right, now let's go and move on to the circle. So write the equation of a circle with the center of H and K, and the radius is 2. Well, just remember the equation of a circle, x minus h squared plus y minus k plus r squared. So we got to make sure we're squaring the radius for our equation. So it's not going to be those two equations. And then just remember, guys, it's x minus -5, right? Squared plus y minus 8. I'm sorry, minus 8. Use those parentheses. So therefore, x minus -5 is actually x plus 5. So therefore, you can see how the answer is D. Next one says, find the center and the foci of the ellipse. So this is an ellipse. So remember, for an ellipse, a squared is always larger. So therefore, you can say a squared is equal to 9. And therefore, b squared is equal to 5. So we're trying to find the center. So the center is obviously going to be the opposite. So it's x minus 5 squared. And this would be y minus 9. So my center is going to be a -5, -9. So that's not it. And that's not it. The foci is a distance c away. So remember, the relationship for a, b, and c is a squared minus b squared is equal to c squared. So we have 9 minus 5 equals c squared. So 4 is equal to c squared. So therefore 2 is equal to c. Since a squared is under my y, that means I'm going to be going up and down. So therefore, if I add and subtract 2 from a -9, that would give me a -11 and a -7. So it looks like my answer is B. So again, like just to kind of give you guys a quick little understanding of that, we're at -5. 1, 2. I don't want to graph all that, but you're down here. And since a squared is under my y, I'm going vertically, so I'm going up and down. That means my y coordinate is changing, not my x coordinate. Whereas this one, they changed the x coordinate. So that's why B was your answer. All right, and last but not least, ladies and gentlemen, we have find the standard form of the equation of the hyperbola with the given characteristics. We have vertices, -2, -4. So let's go ahead and graph this. So we're at -2, -4. 1, 2, 3, 4. We're at -2, +6. 1, 2, 3, 4, 5, 6. We're at -2, -5. So that's going to be down there. And -2, 7. So again, those are the foci, vertices, vertices. Okay. So remember that the hyperbola is in the middle, right? Hyperbola is always in the middle of those 2 points. So therefore, we got to make sure, since that's negative, so my center here is going to be a -2, 1. It looks like that's the midpoint. I'm just going to do the, I'm just going to use the midpoint formula in my head. But you could obviously like plot the points, whatever, to find the center here. But -2, 1, it looks good. So therefore, it'd be x minus -2. So that means x plus 2. So therefore, that can't be it. And that can't be it. All right, so now it's going to be between A and D. I recognize here that my a squared, the distance from my center to my vertice, is 1, 2, 3, 4, 5. So a squared is equal to, well, let's do this. a is equal to 5. So a squared is equal to 25. The distance from your center to your foci then is c is equal to 6. So c squared is equal to 36. Now again, the relationship between a, b, and c for a hyperbola is different than it is for an ellipse. So remember, it's a squared plus b squared equals c squared. So a squared is 25 plus b squared equals 36. So therefore b squared is equal to 11. So obviously A is the only one that has those answers. So there you go, ladies and gentlemen. That is the quiz on conic sections, covering multiple choice as well as some free response. I did have a quick little question that I want to make sure I get to. Quick question as far as is 1 over x linear and then y. So we'll go ahead and explain that one. And then if you guys have any other questions, I don't have too much time for you, but again, I cannot tell you guys again. I'll make sure for those of you that are on my email list, I'll make sure that I send out an email next time to let you guys know when I am going to kind of go live. But I will plan on doing this again on Monday. Or Monday at this time frame. So therefore you guys can just kind of plan ahead and get your kind of questions answered. And then obviously I'm going to do another post here on my Facebook page. Therefore you guys can comment your questions down below. So this actually comes from a comment on the Facebook page. And so therefore I try to check that at least like an hour or two before I'm going live, just to make sure if there's any other questions that I can address from anybody that's going on there. Because it is always kind of hard to see what kind of questions you guys are asking right in. It's time for you guys to type in stuff. The nice thing about at least Facebook is you guys can like always take a picture and then post it on there, and then we can kind of have a conversation about what you're understanding from that as well. If you weren't a math teacher, what would profession would be? Gabriella, I think you also said, I've been teaching for 11 years. This is my 11th year, Gabriella. So, and that's a good question. I really liked, let's see, I wanted to be a teacher. I always wanted to be a coach. I've played sports for a lot of my life, and I always really liked coaching. Let's see, I was also interested for a while, at least my minor was in political science. Let's see, what else did I don't teach any government or any kind of political science classes in high school, though. I also worked construction. I did construction for 8 years. So as far as operating heavy machinery and kind of doing all that kind of stuff, driving excavators and bulldozers, and front end loaders and all that kind of stuff, like that was some stuff I really, really enjoyed. And actually I made more money than when I was a teacher than being a teacher down here. So it was kind of crazy. I remember like my first look at a paycheck, I was like, are you kidding me? Like I was doing better as a, construction worker than I was doing teaching. But I mean, there are pluses and minuses of that. I mean, I loved working construction, but obviously I was making more money because I was doing a lot of, I was doing long hours. Obviously it's in the hot sun, and stuff like that. So, in the long run, I don't know. Teaching was also something that I really want to do. I feel like I have a better impact with, have that social connection, with the students. Whereas construction, though, it's really nice because you get to see all the stuff you get to do. Like, I mean, you're like, yeah, I built that, or yeah, I did all that kind of stuff. So, I mean, it's always plus and minuses, but I don't know. It's, and who knows what happens in the future? It's, right now 11 years, so we'll see how long, teaching goes for me. I still feel like I have definitely some more years that I want to continue growing as a teacher and keep on getting better and better. And then we'll, kind of see. All right. Well, I don't think there's any other questions. You get negative x squared. Yes, Kitty Gamer. Thank you for keeping me honest in there. Would linear graphs, range, and domain be all real numbers all the time? Yes. Basically, when you have a line, that's going to be a domain is be all real number, unless you have some kind of restriction for whatever reason. But yes, Prince Little, that it's basically domain range to be all real numbers. Thanks, Lori. Happy to be able to help you out. All right. All right, guys. Well, I'll go ahead and I'm still waiting for those exponential functions with polynomials. I'm not sure what I actually mean by that. I'm not even sure if I'll be able to help you out to see polynomials. Because I have a question about logarithms. We're not covering logarithms. It's been a while. One of my homework is, can you use the change of base formula to write the expression ln y is divided by ln of 3? All right, hold on a second. Let me get into this. How long have you been teaching? Got that? Do you see? I see. If you're a math teacher, I just want to come here and say thanks for helping out multiplications. You're very welcome, Paul. I'm happy to be able to help you out. It says you got help from man. The best program is Google Slides. I'm not sure what you're referring to on that. I got to address Anna's. Do you think it's possible to become an engineer despite really being really bad at math? Well, I mean, I would just kind of consider, why you want to be an engineer and what kind of portion you want to be an engineer. Because obviously, an engineer, you are going to be required, be doing a lot of like maths. Like actually, I wanted to be, I was originally looking into engineering. And it's kind of funny, like a lot of people don't believe me, but the reason why I got out of like trying to be an engineer, I didn't really enjoy doing a lot of the math. Like it's a lot of math you have to do. So if you're struggling with math, I mean, like I enjoy mathematics. I don't enjoy just doing math problem after math problem after math problem, right? Obviously that's kind of what I do, but I'm teaching, right? So it's a little different. But as far as like I didn't really just enjoy the application of math. I really kind of enjoy kind of a little more of like pure mathematics and like the understanding of mathematics and helping students learn and making those kind of connections, not just doing math problem after math problem after math problem. So, if you're really kind of struggling, I guess it kind of, you look into why do you want to become an engineer or what portions of an engineer do you want to be? Obviously, you can always improve upon your math skills, so don't ever hold that back, as a reason why. But I guess you'd maybe want to think of like, what is it? Because you will be required. The reason that engineering requires a lot of math is you're going to be doing a lot of math. So if you struggle with math, it's either you're going to say, this is something I absolutely want to do and I'm going to get better at, or it's something, well, I only like doing certain aspects of something. And so maybe there's a different occupation that's related, but that doesn't require us doing as much math because you're not going to enjoy that. So that'd be my quick answer for you. Hopefully that kind of helps. Yeah, I mean, you can definitely improve being at math, though that's not the issue at all. I would just say I would just be careful, if you're weak at mathematics, then, doing a job that's going to be, that you're going to be doing something that is going to require a lot of it is going to be, I'm not sure how much you would enjoy doing that. So that's my kind of concern for that. All right. One of my homework questions is, can you use the change of base formula to write the expression as base 3? So I'm not really sure about what really your question is regarding that. I mean, obviously when you have the change of base formula, I mean, the only thing I can go to in this is, if I have the log of log of y with regard to base 3. Well, you can use it kind of looks weird. So log base 3 of y. To use the change base formula, basically all that's doing is just re-changing the base, like for, say, ln of y divided by ln of 3. But the base, like the ln doesn't, like the base, now remember, that's just really a logarithm with a base e. But you can use really any base you want to. You could use the change of base. You could do this as, log base 10 of y over log base 10 of 3. Or you could also do this as your teacher question, I guess, assuming, is log base 3 of y divided by log base 3 of 3. Now, obviously, you can see what happens here is log base 3 of 3 is 1, so therefore that just rewrites it into that format. So just remember the change of base form. It doesn't matter what the base is. Typically, we like the natural logarithm and the logarithm base 10, just because most calculators adjust that. I'm not sure if I'm getting directly to your question, but hopefully that maybe helps in some way. The problem is solve the system. All right, a system of equations. So we'll go ahead and do that next. And then, guys, I'm going to have to cut it off after that. I do apologize. I'll have to apologize for those, but I will be back next week. So hopefully you guys can get some questions into me and get those submitted. So therefore I can take a look at them and make sure I am prepared for the next stream to answer your questions. All right, so we'll do that real quick. All right, but before I get to that, let's talk about why it is, 1 over x. And let's just set this equal to y. Is, y equals 1 over x linear? Well, if something's linear, we know there's a couple formats for linear equations. Let's just talk about the y equals mx plus b, and let's talk about ax plus, or I'll do it in the standard form. Good old the a times x plus by is equal to c. So these are just some different equations. This is slope-intercept form, that's standard form. But let's just kind of forget about the letters besides x and y. Let's just take a look at the x and the y relationship. And what we notice is there's a couple things that are special with the x and y. Both x's in this case, have a number in front of them, but that doesn't really matter. The m, the a, the b, the lowercase b, uppercase b, the c, those can all be any real number. But when we look at x and y, there's something really important that's going on. Or I want a different color. Okay. And what I notice here is that the power of my x in both of these equations is going to be 1. All right. And that is what we're going to look for if something is going to produce a line. And if we look at this as far as in terms of the power function or the identity function for x for all lines is going to be y is equal to x. And that x, again, is to the first power. Obviously, if it's going to be to the squared and cubed, you're getting into your power functions and you're getting into there. But this is what we call the initial power function. And when it's raised to the first power, that's going to give us a line. Now, obviously, as we get bigger, that changes that shape of the graph. So we want the 1 to be 1. And obviously, if we go smaller, then we get into fractions. Then we're getting into radicals and everything like that. So the main important thing to identify if something is going to be a line is making sure that your variable has a power of 1. So I'm not sure what class you're in with this, if you've dealt with negative powers. But an easy way to, look at this is, no roots, or I'm just going to say no radicals. And obviously no, not in denominator. Okay, now obviously your x could be a part of an absolute value function or something else. We could expand on this, but obviously this is a question that's usually in a little bit more of a basic format. So you can see here that this is written in the denominator. Therefore, it's not going to produce a line, because if I rewrite this as a exponent in the numerator, then it's going to be x to the negative 1. So therefore, it's no radical. It's not in the denominator. The power must be 1. So not a negative 1, not a fraction, which would be a radical, or not anything squared, cubed, or to the 4th. Okay. And obviously, another way to check this is just to graph it. And you'll see that this is going to produce a hyperbola, like we discussed in this class, not actually a line. All right, so onto our system equations. I do see Josh threw in a question. I'll see, why do you divide both sides by r? No, Josh, you're not. Dang it. Josh, you're kidding me. All right, last question, I swear. It says r squared is equal to r 5 sine of theta. Okay, I will address that later, but any other questions, guys, I apologize. I'm just not going to have time to. All right, so systems of equations here. Let me make sure I get this one. Let me just make sure I have this written down correctly. Otherwise, I don't want to do something that's going to have weird answers, but I mean, that's definitely possible. I just don't want weird answers because I wrote it down wrong. All right, so it looks good. So typically in this case, we don't want to, so you can see that they have a coefficient for all your x's and your y's. So what I'm going to do is I'm going to want the coefficients to be the same. Now you can get them to be the same, both positive or one be positive, one be negative. Just really depends on how you want to do it. I am going to multiply this bottom equation by -3. So what that's going to do is watch. So I'm going to use the elimination method here because substitution, you have to solve for a variable. It doesn't really look like that fun. So the numerator, or the equation in the numerator, remains the same. When multiplying -3 times every single term here, I get a -27x, a negative, let's do a plus a, let's just write this. Yeah, let's do it as a plus a -6. Oh, was that how it was written in there? You got to be careful. I wasn't paying attention. Yeah, the x's and y's are swapped. Funny, funny people. Always trying to make you be careful. And again, I'm at the end of my live stream. And I'm trying to get tripped up here. But obviously, I quickly noticed that it doesn't work because your variables are swapped around. Who would do that to you? So this is 9y plus 2x equals 25. Okay, so the first thing we got to do is align the variables. So align the variables, 5x plus 6y equals -20. And then 2x plus 9y is equal to 25. All right, so now what we're going to need to do is do two multipliers. So we need to determine, do we want to eliminate the x or do we want to eliminate the y? I'm going to eliminate the x, so therefore I need to find a common multiple of my 5 and 2. So therefore, when I combine these two equations, I'm going to get a 0 for that coefficient. So I'm going to choose 10, and I'm going to make one of them negative. You don't have to. You could subtract the two equations if you want to, but I'm going to make one of them negative, so therefore I can add the two equations. So I'm going to multiply the top by -2 and the bottom by 5. Now, watch what happens as I multiply every single term by these numbers. Okay, I'm now going to produce a -10x plus a -12y equals +40. Down below here, I get a +10x plus 45y equals 125. All right, so now you can see these two equations. I can combine these together to eliminate my x variable, because now when I add these, my x's are going to go to, or the x will have a 0 as their coefficient. So therefore I get a 33y. Are you kidding me? Is equal to 165. All right, so now I'm going to have to break out the calculator because I wrote down something wrong or did something wrong, or this problem just has numbers that are not very nice, which is totally possible. But if you guys do see a mistake, let me know, because therefore I can get that fixed. All right. So anyways, let's divide that. So 165 divided by 33. Oh, equals 5. Oh, I guess I just didn't do my math right in my head. So therefore, divide that, y is equal to 5. So now I know my value of 5. All I need to do to solve for x is just plug it back into my equation. So therefore I have 5 times x plus 6 times y, but I can just use 5 now, equals -20. Now you could have used the other equation if you wanted to, but I chose this one. So now you get 5x is equal to a -50. So x is equal to a -10. And there you go. All right. I know I do got to take a break, Dragon User, but don't worry, this is actually my last question. I got to address this really quickly because it is very important. So we're trying to convert here from a polar equation to a rectangular equation. So the first thing we want to do is, we either need to isolate as far as r's. I think that's what we're doing. I don't know, my brain even hurts. We want to get the r to equal 5 times sine of theta, or 5r cosine of theta, r sine of theta, or r squared equals x squared plus y squared. Now, the first thing we want to do here, though, is we have two r's. So let's get them to the same side. So when doing that, I get r squared minus r times 5 sine of theta equals 0. Now I can factor out a common factor of r. So it'd be r times r minus 5 sine of theta equals 0. Now we can apply the zero product property. So if you apply the zero product property to solve for r, you derive at something that's in. So rather than dividing by r on both sides, which you don't want to do, you don't want to divide by an unknown. You don't know what r is, so you can't divide by r because you don't know how that's going to impact as far as your question. That's not going to provide all solutions. You got to be very careful with dividing by an unknown, which is meaning don't do it. So if you get into the state sign, factor out the r, and then apply the zero product property, you arrive at these two equations. So let's look at this first equation. This first equation says r is equal to 0. Well, what kind of point do I have where our equation for a polar graph is when r is equal to 0? That means the radius is equal to 0. So therefore, it's just a dot, right? So it doesn't really even make any conceptual sense for us as far as a graph that's going to produce as a rectangular equation. So therefore, that is just going to be like a wash. So now we can just focus on this equation. R is equal to 5 sine of theta. And then again, God, my head hurts. We just did this too, so now I'm trying to think of what we want to do. But that's exactly what you're solving for. And then I thought we wanted it to be r times sine of theta. Then I don't want to square. I'm having a brain fart. Dang it. Again, I took on the question right on the end of my live stream. Multiply. I guess the only other thing you can do is x squared plus y squared is equal to 5 times r sine of theta is going to be a y. And then I would just write it as I'm not sure what your original question was, but don't divide by r. That at least I addressed that concern. But if you wanted to convert this to rectangular form, just convert r squared to x squared plus y squared, and then sine r times sine of theta is y, so it'd be 5y. So I'm not sure. I don't think you even asked what my original question was, but hopefully that helps you guys out. Diapers, yes. What? The online thing says the answer for the system problem was wrong. What? I did it wrong? Well, I don't know. I don't see any problem with my work, but if anybody sees any problem with my work, please let me know because it looks pretty good to me. But either way, guys, I am past my time. I got to go. I appreciate you guys joining in the live stream, and I will be back next week. So look out for my stream as well as on my Facebook for me posting for you guys to post your answers, and I will get them there. So, all right, guys, have a good night. Cheers.